Okay, time for a few more questions. A math quiz consists of 8 multiple choice questions. Each question has 4 choices, A, B, C, or D. How many different answer keys are possible? So, if there are 8 multiple choice questions, then this task consists of 8 stages, where each stage represents one question. So 1, 2, 3, 4, 5, 6, 7, 8. Now, if each question has 4 choices, A, B, C, or D, then that means that for each of these questions, there are 4 possible answers. And we know that answers can be repeated because you've all written tests where there's 4 C's in a row, 6 A's in a row, whatever. So for each question, there are 4 options, and we multiply. So our answer will be 4 to the power of 8, or in your head, 65,536. That's a very popular type of question. Next, the telephone numbers allocated to subscribers in an area consist of the digits 3, 4, 5, followed by any 4 further digits. 1, 2, 3, 4. How many different 7-digit telephone numbers are possible? So in this case, 3, 4, 5 are fixed. So the telephone companies decided everyone's number will start with 3, 4, 5. The remaining 4 numbers, however, we can choose any digit. So a popular mistake here is to assume that there are only 9 digits, the numbers 1 through 9, but you can't forget 0. So if you write out all the numbers, or all our digits, from 0 to 9, you will see that there are actually 10 possibilities. And again, it doesn't say repetition is not allowed. It's very common to have repetition in a phone number. So we have 10, 10, 10, 10. And we multiply, we get 10 to the power of 4, which is 10,000. Okay, let's try another one. License plates. Car number plates in a country consist of a letter other than I or O, followed by 3 digits, the first of which cannot be 0, followed by any 2 letters which are not repeated. How many different car number plates can be produced? So we can see, I was counting as we went along, that there are 6 different stages to this task. Let's look at the restrictions. So for the first letter, it can't be I or O. So you need to know that in the alphabet, or the English alphabet I should say, there are 26 letters. So if the first letter cannot be I or O, that leaves us with 24 possible letters. Next, it says it's followed by 3 digits, the first of which cannot be 0. So if the first digit can't be 0, remember there are 10 digits to choose from, so minus the one that's 0, that leaves us with 9 possible options. And then followed by any 2 letters which are not repeated. Oh, whoops, that's the last part, sorry. So 3 digits, the first can't be 0. So this was our digit that's not 0. For the next 2, it doesn't give us any restrictions. So there are 10 possibilities for each. Here we go. And then the last 2 are letters which are not repeated. So it can be any 2 letters. So 26, and then we don't want to repeat, so 25. There we go. And we multiply, and we get a humongous number, 14,040,000 possibilities. Last question. Consider the digits 2, 3, 4, 6, 7, and 9. If repetitions are not permitted, so these numbers cannot be repeated, how many 3-digit numbers can be formed? So here my task is made up of 3 stages because I'm making a 3-digit number. The numbers I have to choose from are up here, and there are 1, 2, 3, 4, 5, 6 altogether. So there are 6 possible numbers that can go first. Whoopsies, let's fix the journal pen. 6 possible numbers to go first. Then there can be 5 to go next since I am not repeating, and 4 to go last. This gives me 120 options. Next it says how many of these are less than 400. So when it's saying how many of these, that means how many where repetition is not permitted still. So if the number is less than 400, so if you want to generate a 3-digit number that's smaller than 400, that means that it can't start with a 9, it can't start with a 7 or a 6 or a 4. It must start with either a 2 or a 3. So that gives me 2 options for the first number, and then it doesn't matter what the other 2 numbers are, so that gives me 5 options, and then 4. Again, no repeating. And again, notice that as we put more restrictions on the number, we have a smaller number of possible outcomes. Next, what if the number is even? So if it's even, that means that it must end with either a 2, a 4, or a 6. So that gives me 3 possible ending numbers. So there's 3 options right here. And again, no repetition, so this could be 5, and then 4. That gives me a total of 60. What if the number is odd? Well, if it's odd, that means it must end with either 3 or 7 or 9. 3 possibilities, leaving me with 5 for the first number, 4 for the second number, and a same total. I get the same number here because in this situation I had the same number of even and odd numbers. Lastly, how many numbers can I make that are multiples of 5? Well, we can tell that a number is divisible by 5 if it ends in a 0 or a 5. And since there are no 0s or 5s in this collection of digits, there are 0 possibilities for the last number. So again, it doesn't even matter what these first 2 digits could be, because when I multiply by 0, I end up with 0. So there are no possibilities for multiples of 5 from this collection of numbers.